Imagine if we had a choice. Yeah, then we'd add fuel to the fire.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So here's a diagram of a calorimeter, and a constant pressure calorimeter gives enthalpy values, but a constant volume calorimeter is called a bomb calorimeter. And to find the enthalpy change per mole of a substance A in a reaction between two substances, let's say A and B, the substances are added into the calorimeter and the initial and final temperatures, so basically before the reaction started and after it is finished, is recorded, and that gives us the delta T value. So multiplying this temperature change by the mass, which you can find the number of moles from, and multiplying it by the specific heat capacity of the substance gives a value for the energy given off or absorbed during the reaction. And so that's why there's this insulating jacket to minimize the amount of heat that's getting in or out of the system. So let's do an example. In a constant pressure calorimeter, something like this, at 25 degrees Celsius, you mix 50 milliliters of 1 molar HCl and 1 molar NaOH. And so it's 50 milliliters of each one. And after mixing, the temperature reaches 31.9 degrees Celsius. So this is like the example I was talking about before. We're mixing A and B together. We're measuring the initial temperature and the final temperature, and using the specific heat, we can figure out how much heat was being released. So, a few assumptions. Assume that the density of the solution is about 1 gram per milliliter, and this is the density of pure water. And so we're also going to use the specific heat capacity of water which is a constant value of 4.18 joules per degree Celsius gram. So in a perfect system, the heat in the system and the heat in the surroundings would equal 0. They would cancel each other out, because that means whatever is being put into the surroundings is taken up by the surroundings. Anything that's put into the system is fully taken into the system. And the heat given off by a reaction is equal to the heat absorbed by the solution. So this can be rearranged to Q system equals negative Q surroundings. Again, this is in a perfect system. A perfect system meaning that no other heat enters or exits the system. So that's really hard, and that's why you need a really good insulating jacket for your calorimeter. So, in order to figure out the Q, or the amount of heat that's released in the system, we can do NC delta T, where the specific heat capacity is 4.18 joules per degree Celsius gram, and we can figure out the temperature change because we have the starting and the ending temperature, and we can figure out the number of moles by using the amount of solution we have in terms of milliliters. We can use the density of the water to get grams, and then we can convert that to moles. So the mass of the solution is 100 milliliters, since we have 50 milliliters of HCl and 50 milliliters of NaOH, multiplied by the density of water. The milliliters cancel out, and you end up with 1.0 times 10 squared grams. And since in this case the specific heat capacity of water has the unit of grams, we can just use this number without even converting it to moles. So Q is going to equal 1 times 10 squared grams specific heat capacity 4.18 joules per degree Celsius gram, and the change in temperature from 25 to 31.9 is 6.9 degrees Celsius. This is a positive number because it was an increase in the temperature. So let's make sure all the units cancel out, grams cancel out, and you end up with a value in joules, which is negative 2.9 kilojoules. So in this case, this reaction is exothermic, since the Q value is negative, and since this is at a constant pressure, QP is equal to delta H of the reaction. Remember, this relationship that we mentioned before now comes back to be really useful, because we can't just look at the heat to see whether it's an exothermic or an endothermic reaction. We have to look at it in terms of the delta H of the reaction. So the delta H of the reaction is negative 2.9 kilojoules, and the volume of the reactants is the volume of the products.
Ain't no justice in these moments.